Okie doke. We're on problem 50. And problem 50 is use the following bond dissociation enthalpies. And I give you the oxygen-oxygen double bond dissociation enthalpy, the hydrogen-hydrogen bond dissociation enthalpy, and the oxygen-hydrogen bond dissociation enthalpy. Use that to predict the enthalpy of the following reaction. 2 hydrogens plus oxygen gives me 2 waters. What kind of reaction is that? What do they call it? It's what? No, but that was a good try.
Is that a redox?
It's a redox reaction. And how can you tell it's a redox reaction?
The elements by themselves, so there's 0.
0 oxidation state elements on one side. The oxidation state of an element changes in the course of a reaction. It's a redox reaction. This particular class of redox reactions, combination with oxygen, otherwise known as what? Combustion. Exactly. So it's a combustion reaction. And so all of this work is done on scratch paper. Let's do it. I'm going to have to draw the molecule plus so just like we did before on the bond dissociation energies, I needed to draw this. I'm going to need to break one hydrogen bond, one oxygen-oxygen double bond, and I'm going to make 2 hydrogen-oxygen bonds for each water molecule, and there's 2 of those. So which one is endothermic and which process is exothermic? Which is exothermic? Bond making or bond breaking? Bond what? Bond making. When you make the bond, and if you think about it for a little bit, just see, the real trick on a test is to slow down, not go too fast. Think about it in terms of the reason these are found in this form as a molecule is because they're bonded together. That means that it basically is a stable state of affairs. It's going to take work to pull them apart. So you're going to have to put some work into yanking those apart. That means it's going to be an endothermic process. I'm going to have to add energy in to get this to fly apart and to get this to fly apart. And then when bonds are made, it's a more favorable situation. Energy is going to be released. It's an exothermic process. Okay, now we just got to take this information, and I have 1 hydrogen, so it's going to be hydrogen-hydrogen bond. There's 1 mole of H2, and it's 436, or actually...
Isn't there 2 of those?
Yeah, isn't it 2?
Is there 2?
Yeah.
Oh, yes, there is. Thank you. Thank you. Thank you very much. 1 mole of H for every 1 mole of H2, and it is 464 for every 1 mole of HH. Now this is on the scratch paper. I'm not going to see the scratch paper. The reason I recommend you do it this way every time is because you can see what you're doing. And you're more likely to... What?
Isn't it 436?
So
Is it 436?
Yeah.
Boy, I wrote down the wrong... Thank you. Thank you. So it's 436 kilojoules. Thank you very much. So that's how many goes into this, plus 1 mole of O2. There's 1 mole of oxygen-oxygen double bond for every 1 mole of O2. and that is, make sure I get the right one, 498. Okay, now that takes care of all the bonds I have to break. Now I'm going to deal with the ones I'm making. So it's going to have a negative sign. It's an exothermic process. So minus, and then I have 2 moles of H2O. There is 2 moles of OH for every 1 mole of H2O. And there is, well, that's the 464. 464 kilojoules for every 1 mole of OH. At this point, I've set it up nicely. Now I can do the calculation. This is, again, all on scratch paper. So I have to first multiply 436 times 2, 12, 3 times 2, 6, 7, 4 times 2 is 872. And then I've got 1 mole times 498, so I add 498 to that. 1370 equals 1370 kilojoules minus, and now I have 2 times 2 is 4 times 464. 464 times 4, 16, times 4 is 24, 25, 4 times 4 is 16, 18. So I have 1856 plus 1370, so that would be minus 1856 kilojoules. And now 6, 5, 4 is 8, 7, 2 is 486 kilojoules. So I have equals minus 486 kilojoules per mole. Which option was that?
A.
Option A. So all you do on the test or on your Scantron is fill in bubble A. But you need to do all of this work on your scratch paper. And I recommend following this format, not just because I'm going to be testing you on that. The reason we're training you to do it this way is it makes the logic clearer. It makes it easier to spot mistakes. You guys spotted a couple of mine. See how easy that is? If you do it this way, you need the practice anyway. You'll be able to track your logic and then correct any mistakes. Now, the one other thing I recommend you do, although I didn't emphasize it, when you take the test, write down, in addition to filling in the bubble on the Scantron, write the answer, write the A on the test, so that if you make a mistake with your Scantron, and like shift a row, skip a question, and then all of your answers are wrong, if you have a hard copy, we can go back and figure that out. So you want to provide me an extra hard copy on the test. That way, we've got some sort of a remedy. Okay? And we can see where the problem occurred, and you'll get the credit. It's also a good idea to take an index card and follow along on the Scantron and make sure you're filling in the bubble for the right number problem. Because that is how it happens. I thought I was filling in number 17. It turns out I filled in number 18, and then everything below that is wrong. Okay? So those are 2 good practices for taking the test. Are there any questions about this one before we move on? No questions?